Hello. We're doing the Wireshark packet operations room. Um, I'll go over the summary part real quick, and then we'll get on to the questions and see how it goes. Let's start with the statistics and read through the task, and then so that we can answer the questions right below. Let's open the Wireshark in the meantime and have it ready. I have the PCAP uploaded here. This menu provides multiple statistic options ready to investigate to help users see the big picture in terms of the scope of the traffic, available protocols, endpoints, and conversations, and some protocol-specific details like DHCP, DNS, and HTTP2. For security analysts, it is crucial to know how to utilize the statistical information. This section provides a quick summary of the processed PCAP, which will help analysts create a hypothesis for an investigation. You can use the statistics menu to view all available options. Okay, so we have the exercise PCAP NG ready here. Result addresses is under statistics right here. This option helps analysts identify IP addresses and DNS names available in the capture file by providing the list of the result addresses and their host names, like we can see here. Note that the hostname information is taken from DNS answers in the capture file. Analysts can quickly identify the access resources by using this menu. Thus, they can spot access resources and evaluate them according to the event of interest. You can use the statistic result addresses menu to view all result addresses by Wireshark. Okay. Protocol hierarchy is again under statistics right here. This option breaks down all available protocols from the capture file and helps analysts view the protocols in a tree view based on packet counters and percentages, as we can see here. Thus, analysts can view the overall usage of the ports and services and focus on the event of interest. The golden rule mentioned in the previous room is valid in this section. You can right-click and filter the event of interest. You can use the statistics protocol hierarchy menu to view this info. Okay, that's understood. Conversations represent traffic between two specific endpoints. It is again under statistics. This option provides the list of the conversations in 5 base formats that are Ethernet, IPv4, IPv6, TCP, and UDP. Thus, analysts can identify all conversations and contact endpoints for the event of interest. You can use statistic on conversation. Okay. On this section, we can see the endpoint conversations, I guess. So these are the Ethernet conversations, IPv4, IPv6, TCP, and UDP connections. Endpoints is again under statistics. The endpoint option is similar to the conversations option. The only difference is that this option provides unique information for a single information field, like Ethernet, IPv4, IPv6, TCP, and UDP. Thus, analysts can identify the unique endpoints in the capture file and use it for the event of interest. Wireshark also supports resolving MAC addresses to human-readable format using the manufacturer name assigned by IEEE. Note that this conversation is done through the first 3 bytes of the MAC address and only works with the known manufacturers. When you review the Ethernet endpoints, you can activate this option with the name resolution button button in the lower left corner of the endpoints window right here. If we click on this, it'll resolve the MAC addresses for a human readable format. Okay. Name resolution is not limited only to MAC addresses. Wireshark provides IP and port name resolution options as well. However, these options are not enabled by default. If you want to use these functionalities, you need to activate them through the edit preferences and name resolution menu. I've done this like a couple seconds ago. So we go to edit, preferences, and then Under name resolution, we enable these two options: resolve transport names and resolve network IP addresses. So once we do that, we can see the resolved names on our packet file. So this is the comparison. This becomes this. Endpoint menu with the name resolution. So if you go to under IPv4 on endpoints, we can now see the address names that are resolved. Okay. Should go to IP geolocation mapping that helps analysts identify the map's source and destination addresses, but this feature is not activated by default and needs supplementary data like the GeoIP database. Currently, Wireshark supports MaxMine databases, and the latest version of the Wireshark come configured MaxMine DB resolver. However, you still need MaxMine DB files and provide that database path to the Wireshark by using edit preferences name resolution MaxMine database directories menu. Once you download and indicate the path, Wireshark will automatically provide GeoIP information under the IP protocol. Okay, do we have this in this machine? I don't think so. Or if we, I don't know where. Endpoints in GeoIP view. Okay. Okay, fine. So the first question asks us to investigate the resolved addresses. What is the IP address of the host name starts with BBC? Hint says resolved addresses can help. Yeah, that makes sense. So we go to result addresses. We're looking for a host name starting with BBC. So if I can just, yeah, that one's just easy as that. What is the number of IPv4 conversations? So for that, I think we would go to conversations, and yeah, the number here I think states the number of the IPv4 connections. So that would be 435. Yep. How many bytes were transferred from micro SD MAC address? Okay. So for this one, let's go and check endpoints. Micro SD MAC address. This one right here. All right, is there any other? Yeah, this should be the one. How many bytes were transferred from? I think it's this one. 7,474 kilobytes. Yep, that's it. The next question is, what is the number of IP addresses linked with Kansas City? Again, let's check the endpoints. So IPv4 tab shows us the country and city related. We're looking at Kansas City. One, two, three, four. Is that it? So if I sort by city and look for Kansas City, I think, yeah, there's just only 4 IP addresses linked with the Kansas City. Which IP address is linked with Blicknet AS organization? We're again on the endpoints. We need the organization. And it should be BlickNet. So if you go up here, BlickNet DOO. And the IP address is here. Okay. That's it. Let's go for the task 3. Next up, we have protocol details, IPv4 and IPv6. Up to here, almost all options provide information that contain both versions of the IP addresses. The statistics menu has 2 options for narrowing the statistics on packets containing a specific IP version. Thus, analysts can identify and list all events linked to specific IP versions in a single window and use it for the event of interest. You can use statistics IPv6 statistics menu to view this info. So if you go to statistics, we have IPv4 and 6 statistics right here. We have all addresses, destinations, and ports, IP protocol types, source and destination addresses. So it all shows up here. This option breaks down all DNS packets from the capture file and helps analysts view the findings in a tree view based on packet counters and percentages of the DNS protocol. Thus, analysts can view the DNS service's overall usage, including RCode, opcode, class, query type, service, and query stats, and use it for the event of interest. You can use statistics DNS menu to view this info. So we can go to statistics and DNS and see the DNS packets from the capture file. Okay. HTTP, this option breaks down all HTTP packets from the capture file and helps analysts view the finding in a true view based on packet counters and percentages of the HTTP protocol. Thus, analysts can view the HTTP service's overall usage, including request and response codes and the original requests. You can use the statistics HTTP menu to view this info. It's right here, I think. So we can do requests and see all the HTTP requests within the packet capture. Okay, so let's have a look at the questions. It's asking us what the most used IPv4 destination address is. So I think it's mentioned here under IPv4 statistics. Yeah, destinations and ports. It's asking us the most used one. Can I just sort by count? I think I have to wait for it to be loaded up. Yeah, we're on the right track. We gotta wait for the upload. Okay. If I do this, I think this should be the most used destination IP. Yep. So the next question is, what is the max service request response time of the DNS packets? So for this, I think we're going to have to look at the DNS section. Request response time. I think this should be the answer, the max value. Let's give it a try. Yep. And the next question is, what is the number of HTTP requests accomplished by radmsn.com? So for this, I think we're going to have to look at the HTTP section. We're going to have a look at requests. I think we can use the display filter maybe. Maybe under load distribution. We're looking for ratmsn.com. Okay, we have a ratmsn.com. B. Okay, radmsn.com, and the count is 39. I think this should be the answer. Yep, that's it. Next up, we have packet filtering principles. In the previous room, we covered packet filtering, how to filter packets without using queries. In this room, we'll use queries to filter packets. As mentioned earlier, there are two types of filters in the Wireshark. While both use similar syntax, they are used for different purposes. Let's remember the difference between these two categories. Capture filters. This type of filter is used to save only a specific part of the traffic. It is set before capturing traffic and not changeable during the capture. Display filters. This type of filter is used to investigate packets by reducing the number of visible packets, and it is changeable during the capture. Okay. You cannot use display filter expressions for capturing traffic and vice versa, if that makes sense. The typical use case is capturing everything and filtering the packets according to the event of interest. Only experienced professionals use capture filters instead of traffic. This is why Wireshark supports more protocol types and display filters. Please ensure that you thoroughly learn how to use capture filters before using them in a live environment. Remember, you cannot capture the event of interest if your capture filter is not matching the specific traffic pattern you're looking for. Capture filter syntax. These filters use byte offsets, hex values, and masks with Boolean operators, and it is not easy to understand or predict the filter's purpose at first glance. The base syntax is explained below. Scope is host, net, port, and port range. Direction is source, destination, source or destination, source and destination. Okay. Protocol, Ethernet, VLAN, IP, IP6, ARP, RARP, TCP, and UDP. Sample filter to capture port 80 traffic is TCP port 80. Okay. You can read more on capture filter syntax from here. I think that's the Wireshark official website. Yeah. And here. Okay. A quick reference is available under capture filters menu. So it's here, capture filters. Okay. Display filter syntax. This is Wireshark's most powerful feature. It supports 3,000 protocols and allows conducting packet level searches under the protocol breakdown. The official display filter reference provides all supported protocols breakdown for filtering. Sample filter to capture port 80 traffic is tcp.port equals 80. I think that's here. And we can add a display filter from here. P4 addresses. Okay, yeah. In order to look for this IP address, we would need to add a filter as ip.address, and the IP address comes. Okay. Comparison operators. You can create display filters by using different comparison operators to find the event of interest. The primary operators are shown in the table below. Equals is this. So if we want to look at a source IP of 10.10.10.100, we would need to type in a filter like this. Not equal would be, okay. Okay. GT stands for greater than. LT is less than. GE is greater than or equal to. IP time to live is this. Less than or equal to would be time to live. Yes. Okay. Wireshark supports decimal and hexadecimal values in filtering. You can use any format you want according to the search you will conduct. Okay. Logical expressions. Wireshark supports Boolean syntax. You can create display filters by using logical operators as well. For and, the expression and, we would need to use double and symbol. Logical and. For example, IP source this and IP source this. Yeah, in order to make a filter for looking for these two IP addresses, we would need to use the logical expression and. The logical or we can, yeah, if you want to look at one of these two IP addresses, we would need to use logical or two pipes. For not, okay. Now usage of not value is deprecated. Using it could provide inconsistent results. Using the exclamation mark value is style is suggested for more consistent results. Okay, so for this one, we're adding the exclamation mark, the logical not, to the beginning of our filter. And this brings up more consistent results, as it says. Okay. Packet filter toolbar. The filter toolbar is where you create and apply your display filters. It is a smart toolbar that helps you create valid display filters with ease. Before starting to filter packets, here are a few tips. Packet filters are defined in lowercase. Packet filters have an autocomplete feature to break down protocol details, and each detail is represented by a dot. Packet filters have three color representation explained below. So if it's green, it's a valid filter. If it's red, it's an invalid filter. If it's yellow, it's a warning filter. This filter works, but it is unreliable, and it is suggested to change it with a valid filter. Okay. Filter toolbar features are shown below. So we can bookmark or use the bookmarks here. We can use the autocomplete feature. Like if I type I, it comes up with all the available options. If I type in IP, it shows us it's a bookmarked option. We can clear the filter, view filter history. And that's that. Next up, we have packet filtering, protocol filters, task 5. Protocol filters, as mentioned in the previous task, Wireshark supports 3,000 protocols and allows packet level investigation by filtering the protocol fields. This task shows the creation and usage of filters against different protocol fields. IP filters help analysts filter the traffic according to the IP level information from the packets, network layer, or of the OSI model. This is one of the most commonly used filters in Wireshark. These filters filter network level information like IP addresses, version, time to live, type of service, flags, and checksum values. The common filters are shown in the given table. So the IP filter would show all IP packets. IP address filter would show all the packets containing the IP address, the given IP address. This filter with port/24 would show all packets containing IP addresses from this subnet. IP source would show all packets originating from the IP address, and the destination would do the vice versa, the packet sent to the IP address. Note the IP.address filters the traffic without considering the packet direction. The IP source and IP destination filters the packet depending on the packet direction. Okay. And here are the examples shown. TCP and UDP filters. TCP filters help analysts filter the traffic according to protocol level information from the packets. That is the transport layer of the OSI model. These filters filter transport protocol level information like source and destination ports, sequence number, acknowledgement number, window size, timestamps, flags, length, and protocol errors. TCP port 80 would show all TCP packets with port 80, and UDP port 53 would show all UDP packets with port 53. TCP source port would show TCP packets originating from port 12345, and okay. TCP destination port, UDP destination port. Okay. Application level protocol filters, HTTP and DNS. Application level protocol filters help analysts filter the traffic according to application protocol level information from the packets. That is application layer of the OSI model. These filters filter application specific information like payload and link data depending on the protocol type. So if we use a filter like as HTTP, this would show all HTTP packets, and same goes for DNS. In order to show all packets with HTTP response code 200, we need to use the filter http.response.code. Okay. For DNS requests, DNS flags response 0. HTTP request method get show all HTTP get requests. DNS flags response 1 show all DNS responses. HTTP request method post would show all the post requests. And query type DNS query type 1 would show all DNS A records. Okay. Display filter expressions, as mentioned earlier, Wireshark has a built-in option that stores all supported protocol structures to help analysts create display filters. When an analyst can't recall the required filter for a specific protocol or is unsure about the assignable values for a filter, the display filter expressions menu provides an easy-to-use display filter builder guide. It is available under the Analyze Display Filter Expression menu. Oh. Okay. Okay. It is impossible to memorize all details of display filters for each protocol. Yeah. Each protocol can have different fields and can accept various types of values. The display filter expressions menu shows all protocol fields, accepted value types, and predefined values. Note that it will take time to require practice to master creating filters and learning the protocol filter fields. Note the first term introduced coloring rules. Now you know how to create display filters and filter the event of interest. You can use the view coloring rules. Okay. Okay, so the first question is, what is the number of IP packets? I think, yeah, that's for that we would need to search for IP. And this one right here should be our answer. What is the number of packets with a time to live value less than 10? So I think it was mentioned somewhere around here, but is it here? Yeah. So we're looking for IP time to live is less than 10. That should actually do it. This should be our answer here. What is the number of packets which uses TCP port 4444? So for this one, we would need to look up for. Is it 632? Yep. What is the number of HTTP GET requests sent to port 80? Okay, so for this one, I believe we would need, we're going to have to use 2 filters, one for HTTP GET requests and the other for the port filtering. So in order to look for the GET methods, we would need this filter. Okay, so we can just turn this into 80. Add the AND operator, AND expression, and then this should give us the answer. 527. Yes. What is the number of type A DNS queries? So this one right here should give us the answer. Okay. It just does not. That's weird. Because it says this filter would show all DNSA records, in the question is asking the number of type A DNS queries. So this one should have given us the answer, but I guess there is something that I'm doing wrong here. What if you check DNS here? Is there a section that says DNSA records? What if you check? So if we just type in DNS.A, is it 51? Yes. So, okay. I don't know if this is something that they have done on purpose, but when I type in the filter that was supposed to show me all the DNSA records, it showed up like something around 100 records, which was not the correct answer. I've gone to the display filter expressions and looked up for DNS to see if there would be an option to look for DNSA queries. Where was it? Yeah, here. And it says here that DNS.A filter would show the DNSA queries directly. So we don't have to type in this filter, and instead we can just look for DNSA records with this way. Okay, next up we have advanced filtering, and this is the last task of the room. Let's go ahead and have a look at the content, and then we can answer the questions. Advanced filtering. So far you've learned the basics of packet filtering operations. Now it is time to focus on specific packet details for the event of interest. Besides the operators and expressions covered in the previous room, Wireshark has advanced operators and functions. These advanced filtering options help the analyst conduct an in-depth analysis of an event of interest. So the first filter is contains. It's a comparison operator, and it is used for searching and value inside packets. It is case sensitive and provides similar functionality to the find option by focusing on a specific field. An example would be finding all Apache servers. An example workflow would be listing all HTTP packets or packets. Server field contains the Apache keyword, and the usage would be http.server contains Apache. Next up, we have matches. It's again another comparison operator. It's used for searching a pattern of a regular expression. It is case insensitive, and complex queries may have a margin of error. An example would be finding all PHP and HTML pages. A workflow would be listing all HTTP packets or packets host fields, match keywords, PHP or HTML. And the user would be http.host matches PHP and HTML. Next up we have in. It's a set membership. Description is search a value or field inside of a specific scope or range. Final package that use ports 80, 443, or 8080. List all TCP packets or packets port fields have values 80, 443, or 8080. Okay. The next filter is upper. It's a function. Convert a string value to uppercase. Find all Apache servers. Convert all HTTP packets server fields to uppercase and list packets that contain the Apache keyword. Okay. Next up, we have lower. The function, convert a string value to lowercase. Find all Apache servers. Convert all HTTP packets server fields into info to lowercase and list packets that contain the Apache keyword. Okay. Next one is string. It's a function. Convert a non-string value to a string. Find all frames with odd numbers. Convert all frame number fields to string values and list frames and with odd values. So string frame number matches 1 through 5, 7, 9. Okay. Bookmarks and filtering buttons. We've covered different types of filtering options, operating functions. It's a little hard to memorize all of these functions and operators, but while doing the while answering the questions, the practice part would make them a little easier to keep in mind. But again, I feel like it's really hard to memorize all of this and come up with this filter right on when something specific is needed. So this will take some practice, and yeah, this will take some like real-time practice. It's time to create filters and save them as bookmarks buttons for later usage. As mentioned in the previous task, the filter toolbar has a filter bookmark section to save user created filters, which help analysts reuse favorite complex filters with a couple of clicks. Similar to bookmarks, you can create filter buttons ready to apply with a single click, creating and using bookmarks. Okay, so yeah, I can just type in a filter here and then click on the bookmark icon and save this filter. And then use the display filter from here, from this arrow, down arrow. Okay. Profiles, Wireshark is a multifunctional tool that helps analysts to accomplish in-depth packet analysis. As we covered during the room, multiple preferences need to be configured to analyze a specific matter of interest. It is cumbersome to rechange the configuration for each investigation case, which requires a different set of coloring rules and filtering buttons. This is where Wireshark profiles come into play. You can create multiple profiles for different investigation cases and use them accordingly. You can use the Edit Configuration Profiles menu or the lower right button, bottom of the status bar into profile section to create, modify, and change profile configuration. Okay, so it's edit configuration profiles and then arrange the profiles from here. Okay. All right, so let's have a look at the questions. The first one is asking us to find all Microsoft IIS servers. What is the number of the packets that did not originate from port 80? Okay. Contains operator. I remember seeing that. Okay, this one. The HTTP server contains Apache. So this, for this one, we need HTTP server contains. What do we need? Microsoft IIS servers. I can just try and look for IIS, I think. And we need another operator. Did not originate from port 80. So for this one, we're going to use I think it was in No. Well, for this one, we need not. So that would be this, I think. Okay. It's a warning filter that may come up with an inconsistent, like with an incorrect answer, but yeah, it did actually. Oh, okay. I think I found the problem. It says not originate from. So instead of TCP port, I have to go for source port. That is not 80. Let's see if it's 21. Yep, there we go. Yeah, I confused it with direct port. So we need to read the question carefully. It says originate from. So that should be the source port, not 80. And we're looking for Microsoft IIS. So that should be it. Find all Microsoft IIS servers. What is the number of packets that have version 7.5? So this one gives us all the Microsoft IIS servers, which are 353. We're going to have to look at the number of packets that have version 7.5. Matches operator can help. Can I do this? Would this work? Nope. What if we do... Like instead of using matches, can I not use contains for IIS and 7.5? Because we're looking for the number of packets that have both. This might work actually. Is it 71? Okay. Yeah. What if... Okay, I could not find the answer with the matches operator, but I did find it with the contains operator, which was, I believe, easier. Moving on to the next one. What is the total number of packets that use ports 333, 4444, 9999? So this should be easy. We're gonna have to have 3 different filters for 3 of the ports required. This should be TCP port. So it's asking us, I believe, is to use the OR logical operator. So it should be TCP port 4444 or TCP port 9999. without the... Okay, this is not a valid one. Okay, that should... Okay, we should have... We got to do it with the lowercase. So TCP port 3334444 and 999. Should be this. In operator can help. Okay, I keep finding the answers with different options, but they work somehow. Okay, TCP port in. We're looking for 3333 4444 9999. And this would come up with the same answer. What is number of packets with even TTL numbers? String and matches operators can help convert to TTL field to string with the string operator and filter the 02468 regex value with the matches operator to find the even TTL numbers. Oh, okay. String and matches operators. Convert the TTL field to string with the string operator. And filter the regex value with the matches operator to find even TTL numbers. Let's have a look. String frame number matches this. Convert all frame number fields to string values and list the frames in with odd values. So we're going to start with string. TTL field to string with the string operator. So it should be would it be possible to find anything string related here? I doubt it, but so we've got to start with string. So I am sure that the string and the matches part is okay, but I'm not sure about the how to look up for TTL number. Let's try this one out. Okay, it's not going to copy it. Okay. So this came up with this. It's not the right answer. So I'm looking up for how to look out for time to live and which value that I need to use. Okay, I had to look up for write up for this one, and found the value found out that the value should be ip.ttl, and when search for with this filter, it shows up 77,289, and that's the right answer. I could not find which string I should filter out. I didn't know how to filter TTL value, and that it should have been ip.ttl. So I had to look it up. Next up, we have change of profile to checksum control. What is number of bad TCP checksum packets? So I think we can do it on configuration profiles. We have to change it to checksum control. This new profile is custom to detect checksum errors. Bad TCP checksums are shown in red and black colors. Use the packet list pane details or the display filter expression manager to create a required filter. So under expert information, we should have the bad checksum count. For bad TCP checksums, it's this one, I think. It directly shows us the answer on expert information, but I'm trying to find out whatever. Use the existing filtering button to filter the traffic. What is the number of display packets? Okay, use the existing filtering button to filter the traffic. What is the display packets? So the existing filtering button is this. And when I use this filter, it shows up 261 packets. So this should be the answer. The button is available in the checksum control profile. Yeah, it's this one. And this was it. It was a little challenging, I'm not gonna lie, but it was a really well thought, well structured room, again by TryHackMe. I've learned a lot. I wanted to share my study session with you, and show how I study and how I learn. This is going to be my first video under cybersecurity study sessions. There are a lot more to come, but yeah, thank you for watching. See you in the next video.